A fan labeled 88% efficient can still be the wrong energy choice. And an FEI of 1.25 does not mean 125% efficiency. Those numbers answer different questions. In the next 4 minutes, we will follow every watt from the electrical terminals to the moving air, calculate one real duty point, and show exactly what FEI adds. Start with the useful output. Air power is airflow multiplied by fan pressure. Use cubic meters per second in pascals, and the result is watts. If a fan must deliver 2 cubic meters per second at 600 pascals, the useful air power is 1200 watts. This is the work the airstream receives at that defined pressure boundary. Now follow the input. Electrical power enters the controller or drive. Some becomes electronic and motor loss. Shaft power reaches the impeller. More is lost through leakage, recirculation, turbulence, disc friction, and a poor match between impeller and housing. What remains becomes useful air power. Wire-to-air efficiency therefore equals useful air power divided by electrical input power. If the input is 2000 watts, 1200 divided by 2000 gives 60%. This boundary matters. Motor efficiency measures electrical power converted to shaft power. Fan total efficiency compares air power with shaft power. Wire-to-wire efficiency includes the motor and drive. 3 percentages from 3 different boundaries cannot be compared as if they were the same metric. Static and total pressure also produce different air power and efficiency values, so always read the test definition. Efficiency is not one permanent number. On a fan curve, each airflow and pressure combination is a duty point. Efficiency normally rises toward a best efficiency region and falls away on either side. Selecting a smaller fan at high speed, or throttling a fan far from that region, can waste energy even when its catalog peak looks excellent. The motor, drive, and impeller must be evaluated together at the required point. Now add fan energy index. FEI compares the electrical input power of a standardized reference fan with the electrical input power of the actual fan at the same airflow and pressure duty point. In compact form, FEI equals reference fan electrical power divided by actual fan electrical power. The reference is conceptual. It is not another supplier's fan and it is not a fixed efficiency percentage. Suppose the standardized reference requires 2.5 kilowatts at our duty point, while the actual fan requires 2.0 kilowatts. 2.5 divided by 2.0 gives an FEI of 1.25. At that point, the actual fan uses 20% less input power than the reference, because 1 minus 2 divided by 2.5 equals 20%. Again, FEI 1.25 is an index, not 125% efficiency. Move to another duty point and both the actual input and the reference input change. That is why FEI creates an operating range rather than rewarding only one catalog peak. A good selection keeps the expected duty profile inside an efficient region, including partial load operation when the system spends most of its year below design airflow. The laboratory result still needs an installation check. An obstructed inlet, an elbow directly at the fan, a poor outlet plenum, a dirty filter, or the wrong control strategy can move the installed operating point and erase expected savings. Use the system curve and load profile, not only a free air rating. For a defensible comparison, request the tested airflow and pressure definition, electrical input power, fan speed, efficiency curve, FEI at the selected point, motor and drive configuration, and the applicable test or regulatory method. Compare every candidate at the same duty point and the same boundary. The takeaway is simple. Efficiency tells you how much input becomes useful air power within a defined boundary. FEI tells you how the complete electrical fan system compares with a standardized reference at one duty point. Neither replaces the fan curve. Put the required airflow and pressure first, then compare power across the real operating range. If you want a second check on one operating point, send Longwell the airflow, pressure, voltage, control method, and duty profile. We will return a curve-based selection with the comparison boundary stated clearly.